So let's look at the next question, number 22. This one's a little more challenging than number 21, but all of our approach and all of our questions are going to be the same. We have a border, which is y equals 2x, y equals x, and x equals 1. And we have the x-axis, which is the axis of revolution. Our questions that we need to answer in order to pick the right approach: is this a dx or is this a dy problem? And should we use circles or disks? Those being the same thing, circle is a disk. Or should we use washers? Those are our questions. We could go ahead and draw the picture, and that might help us answer the questions. But I want to stress that we can answer these questions without a visual by focusing on the descriptions. And then we'll create the visual later, just for general help. The answer to the first question, dx or dy, is dx. And the reason is our axis of revolution is horizontal. The answer to the second question, circle, disk, or washer, is washer. And the x-axis, which is also y equals 0. Y equals 0 is not any of the three equations that represent our border. It's not a border, and that's why we know it's a washer problem. So dx, because we have a horizontal line, and washer, because our line isn't one of our border lines. Now when we create the picture, hopefully we can see that true from the visual perspective. My scale is going to be zoomed in just a little bit so that the picture is clear. But we have the line y equals x. We have x equals 1, which let's call that 1, 2, 3, 4, maybe 5 spaces total. So we have x equals 1. And then we have the linear equation y equals 2x. Which looks approximately like that. Let's highlight the region that's bordered by these 3 lines. So that blue triangle, the question is the region, and that blue triangle is going to get rotated around the x-axis. Our big radius and our little radius are going to be based on identifying outer and inner functions. The line y equals 2x is farther away from our axis of revolution. So let's label y equals 2x our outer. The line y equals x is closer. It's the lower boundary, and it's closer to the axis of revolution. So let's label that our inner. We've identified dx, and we've identified washer. We've identified the equation farther away, so our outer equation. We've identified the equation with a function closer to the axis. So we've identified our inner. We have all the pieces in place to go through our slice, approximate, integrate steps. We've identified washer, so we know that the area of a washer is pi big R squared minus little r squared. For the approximate step, our goal is to rewrite a of big R little r as a of x. That's our goal. To do that, we need to rewrite big radius using x. Then we have a process, outer minus axis. Our outer function is 2x. Our axis is 0. So 2x is our big R of x. We need to identify the function for our little radius. Our little radius is inner minus axis. Our axis of revolution, or our inner function, is y equals x. So x. Our axis of revolution is y equals 0 minus 0. So function x is our inner function. We have outer function as a function, or outer radius, big radius as a function of x, little radius as a function of x. That's going to allow us to rewrite area as a function of x. The area is pi, 2x squared minus x squared. And since we want to do this antiderivative by hand, the more we simplify the area, the easier that's going to be. We have 4x squared minus x squared. And then we have like terms that can be combined. So this is pi 3x squared, which is 3 pi x squared. Our last step for setup after slice and approximate is integrate. And I want to use blue because this is our goal. This is setting up the calculus. The volume will be equal to the integral from a to b of a of x dx. It should be pretty clear from our picture that a is 0. And it should be pretty clear from our picture that b follows the vertical line y equals 1. If we did not have a good visual, we could just look at x equals 1 as a clue, and then we could set these equal to each other and show that x equals 0 is an intersection or the beginning of our area. So we have the integral from 0 to 1 of 3 pi x squared dx. For the homework assignment, I did not require you to work this out by hand, but we're going to go ahead and flip to the next screen and use antiderivatives to calculate this by hand. It's just good old-fashioned practice. So the volume is the integral from 0 to 1 of 3 pi x squared dx. We have a constant, 3 pi, that's being multiplied by the function x squared. That gives us the ability to factor out 3 pi as a constant multiple and just focus on the antiderivative of x squared. This isn't mathematically required, but it's a simplification process that makes life easier on yourself, and I strongly encourage it. The antiderivative for x squared is x cubed over 3. Our value of a is 0, and our value of b is 1. So this will be g of b minus g of a. 3 pi, and then 1 cubed over 3 minus 0 cubed over 3 are equal to 3 pi times 1/3, which is equal to pi. Smiley face with hair, specifically a mohawk. For the next question, number 23, please check out the next clip.